Hi, I'm Zianshu from Group 110. In a few minutes, I'm show you how we turn real-time road data into safer local signal decisions. So a corridor runs with a less delay, shorter queues, and lower emissions. Our recipe is simple. We use the edge-centric control at each intersections, tiny neighbor updates, and when available, a small vehicle intent hint. First, let's focus on the problem and the target in one view. As we can see, cities already have sensors, but decisions sit far away and light act alone. What works here often fails one block later. Turning a signal node moves queues downstream, and cloud control at latency and cost. Our target is to keep decisions at the roadside, exchange 2 to 5 seconds summarize between the neighbors, and use a light V2I hint to cut the delay, queues, and emissions. Field systems like Sutrack show decentralized coordinate control can also deliver the coordinate level games. And with the context, here's the system in one picture. And we can see the left to the right, sensors and the V2I fuse the roadside edge node. We clean and fuse data into the unified state. A controller chose which phase and how long under the familiar safety rules. If anything looks wrong, we just fall back to a rule set. Neighboring lights exchange tiny summarize, arrives coming, downstream tide, capacity left, to align green waves and avoid spillback. We track KPIs and use the Sumo digital twin for pre-training and fine-tuning. This slide sharing echoes like a press slide and code slide share just enough across the neighbors. Next, let's focus on the control loop. We split the control loop as the 4 different ways. C is about the edge box turns raw feeds into a compact state, like queues, approach speed, earlier spillback. Think is about choosing like the phase and green time within a safety rules, minimum and maximum grims and intergrims, pedestrian clearance. And do is what we execute. If data comments behavior, immediately fallbacks access the safety fields. And finally, everything is the edge local, and we run locally and pretend in the sumo, and then we benchmark against the max pressure to stay honest. Next, we will validate this on corridors. We test the 5 to 10 intersections into the rush hour and the incident case, and we use the fixed time, actual, and maximum pressure, plus the no vehicle intent variant as the baselines. We report 4 KPIs like average delay, queues length, and throughput, emissions, and run ablations to isolate the value of the neighboring share. And we start in the digital twin and then propose the small pilot next. Finally, the impact today and the path forward. And today is a smoother grims, fewer spillbacks, lower emissions without sending control to the cloud. Tomorrow is a natural path to a connect autonomous vehicles as more cost intent. Think of it as a software upgrade to cabinets you already have. And local brings tiny whisper, safety follow. Thank you.